Hello, in this video I'll be discussing some of the challenges of a distributed model-based design project. And what I mean by that is a simulation project where you're getting subsystem model components from other organizations. This could be components from other companies or from other departments within a large corporation. To illustrate this, I've shown you what a ballistic missile defense project might look like. You've got the sponsoring organization, and you got other organizations providing subsystem models. Typically, when you start one of these projects, you start with an ICD. You make your best guess at what it should be, and you send it out to the stakeholders for review. They review it and send it back to you. You might have to prod them along to get their input, but eventually you do get it. You merge the changes, then you send it out for review again. You might need to go through this iteration a few times, but eventually everybody gets the final ICD. Then they start building the components and sending them back to you. Once you get the components back, you realize you've got a big problem on your hands. The components just don't work together. I've been on several projects like this in my career, and they never work the first time. It usually takes a lot of time and many iterations to make it work. So what you do is you cleverly nominate one of your analysts to be the simulation integrator. This guy is in charge of making the simulation work. He can't do it alone. He needs help from the subsystem modelers in order to get it to work. And it's a very, very frustrating job for this integrator because he doesn't have authority over them, but he needs their support. Even though you've delegated this to one of your employees, you still have to get involved in order to get everything needed. Eventually, you get everything you need to integrate the components, and then you're able to create an integrated simulation, and everybody gets the same simulation. All of your analysts have the exact same simulation. It doesn't need to be this hard. With SystemBlend, you start a little bit differently. Instead of starting with an ICD, you start with System Designer. It's a desktop application that you probably want to launch as a teleconference so that all the stakeholders can be involved. And with it, you graphically define your design for the simulation. You define the components, their interconnectivity, and it makes sure you don't miss important but small details such as multiplicity of connections or units. Once you've got the design captured, it generates a design database. Next, your subsystem modelers launch Component Guide, which is the next desktop application. It takes in the design database, and the component developers use it to generate a wrapper that is specific to their particular components. Now, the wrapper is an ordinary Simulink model that's empty except for the interfaces. It's got the inputs and outputs that exactly match the design database. The subsystem modelers then exit Component Guide, and they use ordinary Simulink techniques to fill in the model behavior. SystemBlend is not present at this point, so SystemBlend does not constrain what you do to fill in the model behavior. To illustrate how this works, I've animated the interceptor contractor so you can see the interaction between Component Guide and the model developer. Once the model behavior is filled in, the developer goes back to Component Guide, which inspects the model and sees and determines if anything has changed in the interface and makes sure everything is hooked up. It points out any differences, and if there are any, the component developer exits Component Guide and again, using ordinary Simulink, addresses the issues and comes back to Component Guide. Once Component Guide is happy, it sends your component back to your group. Meanwhile, the other organizations are working with Component Guide in a very similar way. Notice that Component Guide has become your proxy in these other organizations. It holds them accountable to your design so that you don't have to. Once you get the components back, your next step is to launch Integration Master. This is a third desktop tool. It takes in the components and lets the analyst create their own simulations. They create these simulations without a deep mind meld or without an integration effort. They use simple drag and drop, and they can build a simulation according to their particular needs. In addition, they can explore different design configurations as needed for their particular needs. Thank you. If you'd like a demo or a free trial copy, please visit blenddynamics.com. Thank you for your time, and bye-bye.